My name is Inés Cámara Leret. I am an artist based at Somerset House Studios in London, and my work primarily deals with exploring life through materials that are unseen, static and inert. Spit crystal is essentially a perfectly ordered crystal of saliva grown alongside the salivary researchers and the crystallographers based at King's College London. So the first spit crystal that was grown was commissioned by Science Gallery London through their open call of Mouthy, and this is how I met the researchers Brian, Alki, Jack, Matt and Lucy.
When I first met Inés, she presented this quite beautiful crystal and she called it a spit crystal. And if I recall rightly, she'd been spitting in a bucket for a month or so, and then had thrown in a whole load of aluminium sulfate and let the kind of water evaporate off, and it left a crystal. So obviously saliva is used in the making of it, but my initial thoughts were this is not a spit crystal. You know, this is not any of the components of saliva crystallizing, but just an aluminium sulfate crystal. And that was I think one of my first comments I mentioned to Inés, and kind of the initial reaction, okay, great, let's make a spit crystal then. We took the saliva over to the crystallography department. They did their crystallography magic. We talked about it, and I persuaded her to dispense with the alum, which was just a salt that would grow large crystals, and see whether we really could crystallize spit itself. Taking some salivary fluid and letting it dry out, and in a thin layer these beautiful fern patterns occur, apparently differing according to the source of the salivary fluid, because what must be in the salivary fluid is a mixture of salt and protein. And I mean, I know about proteins and protein crystals, but what exactly was going on in these ferning patterns we really didn't know, and we looked at them in absolute amazement, and you could, because they grow so quickly, you can watch the kinetics and the growth of these crystals. So it got really exciting at that stage. I'm just looking at these ferning patterns, but still Inés wanted a crystal that you could pick up and put on our diffractometer and make measurements the way we make measurements on our antibody crystals.
After a few months of work and a lot of conversations that we had, a lot of exchanges in information and how we saw the different materials and what we were doing with these processes, we were able to grow a crystal from saliva.
And eventually, to our utter amazement, one evening we actually saw this happen. And amongst these fern patterns were some single crystals. And Alki, a member of my group, very experienced crystallographer, was able to pick up one of these tiny crystals. It was of salt, but it had grown out of one of these ferning patterns, and she put it on the diffractometer and collected some data.
When we were lucky working on the spit crystal, we saw this crystal, which for me was huge and for Inés was tiny. We wanted to shoot the crystal with X-rays, as I would do for my research anyway, and see how this diffracts, and then try to understand what is in this crystal, what have we crystallized, because it could only be one thing that we have crystallized. What we did some mathematical calculation of the diffraction of the spit crystal, and that was sodium chloride. So, which it was cool, because I'm a protein crystallographer, so that was the first time that after so many years working with crystallography, I managed to see salt crystal and solve it manually. The result of the spit crystal and the fact that you either see crystals or see ferning patterns led to a new collaboration with the name Atlas, and also another more scientific collaboration. It was the desalination of seawater.
Atlas is a way of reapplying what we've learned from a previous collaboration on a microscopic level to a worldwide problem that we have, which is our access to fresh water.
The Atlas project is looking at the same process that we did with spit crystal, with the ferning ability, but actually using seawaters as the fluid involved. So we've been using protein to create these ferning patterns.
The idea behind it was to manage and get clear water without salt just by adding some drops of proteins into seawater, and then wait for the ferning to happen, and then salt go away, and then we get nice water that people can drink.
Desalinating seawater is a very energy intense process, because basically they use what's called reverse osmosis, which is whereby they pump seawater at very high pressures through tiny holes in tubes, and that takes a lot of pressure and a lot of energy. So actually desalinating seawater is a very energy intense process, and that's why it's not really applicable to all the countries of the world or the economies of the world. It's only for the very richest. Even if we could only reduce energy costs by 10%, for example, you know, say it was only a preliminary step in the whole desalination process, it could have such a big impact that actually it's easily worth the, you know, exploring these ferning processes.
We've begun to create an archive of seawater. We're inviting everyone across the world to send us samples. People have actually been incredibly generous, and not only have they sent me samples, but they've also sent me notes, cards telling me about their relationship with the sea. I've gotten a red envelope from Chi, which in his culture is a sign of good luck. Also people that have sent me images of the places that they actually collected the sample from. The fact that people from across the world have sent me samples means that I guess hope isn't lost in that way, that there's still a very, there is still a huge amount of people that engage with the ocean and that connect with the ocean in a very, very different way to what we do with the land. And what we're doing with those samples is we're studying both its composition, so any traces that it may have, but we're also observing how it crystallizes and what ferns it creates.
It's quite cool that we get to see differences in ferning patterns across the globe, to see if there's any variation.
It's going to be important to understand what is actually happening as well as just observing it. And we hope that X-ray crystallography will be able to contribute to that and tell us exactly what the composition of these ferns are.
It's been really interesting to me to see the project, the collaboration develop from this spit crystal in one person's hand to drawing seawater samples from across the world. It really plays into the wishes I had at the beginning of getting involved with the work.
I think collaborating with Inés has been great, because sometimes in research you become very tunnel visioned and narrow focused, but actually with talks with Inés it's been great to take a step back and see like a broader picture and collaborate with other groups, which has been great.
It's been very interdisciplinary. The X-ray crystallography here in the Randall Centre for Biophysics, and of course with the Dental Institute and the Salivary Research Group, and then of course involving Inés and the artistic side as well. So it's been a very wide collaboration. Spit crystal and desalination of seawater, extraordinarily diverse but fascinating ideas.